Hi! So in this video I want to show you how you can do a refactoring. I have chosen a code related to Sudoku, a brute-force Sudoku solver. So I hope you know about Sudoku. If not, I will quickly show you the rules. This code is actually written by quite a famous person in 2005 in Java 5 by Patrick Chan, right? And he put this on his website at the time and wanted to show this as an example of a very short, small example. His goal was to write this in the minimum amount of code that is possible, he told me. So he might have had his reasons. Today we will approach this a bit differently. We will assume, we want to make this super readable. We want to write this in an object-oriented way, and we will also use whatever is available at the moment, now with Java 12, that we have in 2019. So we want to use some more modern techniques that he never had available, right? And I picked this code for various reasons. Well, when I first had the idea, I wanted to show you some real business code, complex with hundreds of classes, with thousands of lines. But I realized soon this is not possible because, well, A, it's very complicated for me to show this in like an hour. And B, it's also really complicated for you to be able to follow me, right? So for this reason, I decided against it, also because it's even quite hard to find a company that would be willing to show me the code. I mean, every code has kind of a copyright. Even that code here has copyright, even if it's just some stupid example code. But I asked Patrick Chan specifically for permission to touch his code and show it here, and he gave it to me, so big thanks for that. So anyway, so I also really like this code because it shows a few things that I usually see in legacy code. One is there are no tests, right? And that is what makes it so difficult to refactor this code, right? Because whenever we touch it, we will not know, was the code working before? Is it still working now? Difficult, because code tests also act like a specification, and we don't have any specification here other than the code and the documentation in the code. But documentation can often lie, so this is really difficult. Now, because everything is difficult, it's like a hack and end problem that people say, oh, I would want to refactor the code, but for the refactoring I would need tests. But I can't write the tests because I can't understand the code, and because I can't understand the code, well, let's just not do anything, right? Well, for me personally, as a craftsman, that is the worst kind of solution, and I would not do that. I think we have to continuously refactor code, and this is why I want to show you how we can do that, even in difficult situations like this, without any tests, right? Because on the other hand, let's face the fact, even if we have the perfect clean code written with TDD, written with 100% branch coverage, right? Even that is no guarantee that you will never have a bug, that it will never fail on production. It will, right? And I know because I did all that, and yes, it still failed on production. So we have to work on something else first, and that is we have to minimize the consequences that what happens if it breaks on production, right? There are specific techniques for that. And one technique is, for example, to have a canary release. A canary release you can perform easily with tools like Kubernetes and Istio, but that would be a different topic, not of today. But there you can have one production release, and then you have your second release. That would be, for example, our refactoring. And you only show that to a small percentage of your users, for example, 1%. And for example, the users are only the users of your company or your department, right? In this way, you can really mitigate the risk. So this is something that we should focus on. And we should still perform refactorings. But just because we say, okay, we do this, does not mean that we can go crazy and we don't have to care about anything. We have to be extremely, extremely careful. We have to perform in baby steps, right? Always perform what the easiest simple thing for you. I mean, that's something relative. What is easy for you might not be easy for me, and vice versa, right? And that is okay. So just pick the easiest thing for you at the time. And the more you touch the code, the more you proceed with the code, the easier it will get for you personally to understand the code, and the more risky operations you are willing and you can touch and perform, right? So this is why I usually start with things like just an automated code formatting, right? So I would just trust on my IDE that when I tell it reformat my code, it will not break the code, right? And whatever IDE you're using, I'm using here IntelliJ IDEA and I really like it, but there are other IDEs, for example, Eclipse or NetBeans, they all have these kind of refactoring capabilities. Okay, so I don't know if you know Sudoku, I hope you do. If not, let's just quickly look at it. And to be honest, when I started this refactoring, well, I knew about Sudoku, that it's a game and that there are cells and numbers, but I didn't know the rules in detail. And this was one of the first mistakes that I made, because obviously I still also continuously make mistakes. And that was I underestimated the effort of this refactoring. It's just like 200 lines of code and it looks quite simple, but it's not so simple as you might think, right? So never underestimate things. There are in 99% of the cases, they are harder than it seems. And if we underestimate it, then we run into trouble. And I did run into trouble, so I had to go back. I had to learn about Sudoku in detail. I bought a Sudoku booklet and I played a few Sudoku games. I read about it. And this then enabled me to properly do the Sudoku refactoring. So if you now have the time, please, first of all, I will tell you a bit, and then also maybe you want to also learn about Sudoku by yourself and do a few Sudokus before you continue watching this video, okay? Because to properly understand what I'm doing, you should really be able to follow me, what I'm doing, because I can't explain that in detail here within the time that we have. So anyway, so we see in Sudoku, we start with, we have a board. We start with it, and at the end we also have a board, but when we start, this is an empty cell, so some cells are filled, others are not, and by following some strategy, some logic, we have to find out the numbers that are missing, right? Sometimes there are even more than one solution. Here, for example, we found 2 solutions. There might be more solutions, but we stopped at 2 because we didn't want to calculate this forever. This is part of the algorithm logic that we will look at. So anyway, sorry, I'm going away. So back to Sudoku. So here we have rows, 9 rows and 9 columns. Every row, every column and every box, here this is a box, has 9, can contain 9 numbers. And numbers that can be from 1 to 9, right? So the number 9 occurs very, very often in Sudoku. Really important, right? And so there is another rule, and that says in every row, in every column, can't mark down, and in every box, you see we have here also 9 boxes, these subgrids, have to be all the numbers from 1 to 9 and no duplicates. So there should never be 2 1s or 2 3s in a box, in a row, or in a column. Really important. And that's what makes it complex, difficult. So if you like math, there we call this, it's an NP-complete problem. In layman's terms, that just means that it's really difficult to solve for humans as well as for computers. For computers, there are various different strategies of how we can solve that. The one that we are looking at today is the brute-force solver, which is just, trial and error. It just tries to solve that. And it's actually not the worst algorithm because A, this is guaranteed to solve the problem, and B, with our very modern computers today, this is quite fast actually, right? And I also like this because, it has some complexity, but still not too much that we can tackle that within our time, right? Because there are other algorithms that are more complex and that might just be too much for the time here. So how does the brute-force solver work? It iterates over the whole board, right? And it starts to find the first empty cell. In this case, this would be this one. And now it tries to find out what number can I fill in here. Can I fill in a 1? No, because it is already in the row. Can I fill in a 2? There is no 2 in the row. But wait a second, there is a 2 in this column that the cell also belongs to. So we can't pick a 2. 3 is also not working. 4 is in the box, also not working. What about a 5? 5 is down here, but this is a different box. Yes, 5 seems to work. And as you can see here in the solution, 5 is actually also the solution. So this in this case worked. But there will be other cases where you would maybe say, oh, 2 is not here, 1 is here, we can't pick 1, but 2 seems to be possible. But maybe we can't put the 2 here because later on down here there is a 2, and so we are blocking ourselves, right? And in this case, when we are blocking ourselves, when there's different possibilities, there could be a 2, but there could also be a 3, and we have chosen the 2, and now later on this didn't work. We have to roll back the whole thing, and we have to try again with the next number until we will find one combination in the whole grid that works out. So there will be thousands, if not millions, of combinations that have to be tried out, but computers are really fast in that, right? So this is how the brute-force solver works. Okay, so let's look a bit more at the code. So here we have the 2 classes at the beginning, the Sudoku solver and the grid. So the Sudoku solver has the main method. It just starts, then it forwards from the starter parameter, from the console basically, a string. This one is read from a file reader. By the way, here I found a small bug, which is, well, the file reader isn't closed, and this is one of the things that we should do better. Also, I don't like that throws exception, but one step at a time, we will tackle this later, okay? As I said, we will perform in baby steps. Then we are creating the grid in a static method, and now we are starting with a list of solutions, and we will start our solve method that will recursively work on finding a solution. And when we're done, we are printing out the original grid that you saw here, and then for all the solutions, we'll print them out. Okay, so how does this solving logic work? We're finding the first empty cell, right? So this is actually the cell index. And here, if no empty cells are found, a solution is found. So this is also something that I usually see in legacy code. There's lots of documentation, and the code lacks to express the same thing in the code, right? So in my opinion, my strategy, we should aim to express the same thing in the code. I, in short, often say documentation is evil. This is partially true because there are still reasons where documentation might make sense, but you shouldn't try to document what can be documented in code. So this is also one thing that I would change. Now we're cloning the grid. Clone is also problematic, as we'll later see. Anyway, so we're adding that to the solutions so that we can later print this out. And here's the actually solving logic. So we're iterating from 1, so n. This is also something that I see very often in legacy code that is not properly written out. So this is the number from the number 1 to the number smaller 10. So what he means here is 9. So from the numbers 1 to 9, he goes through the grid, sets a number. In here is also a validation. This is something that we should fix, because it's actually not following the single responsibility principle, because it's doing validation and setting. But anyway, so in there is a validation, and if this is valid, it will set that, and then it will continue recursively with the next number. And here, it will then, next step, it will clear again this position for 2 reasons. First of all, if the position didn't work out. Second, also, because to find further solutions. So obviously, I mean, this is working recursively, so this is a bit hard to understand. This will again call the solve method. This will again call the solve method. And at the very end, there will be this clear, right? So don't get this wrong. This is like a stack that is building up. Okay, so the grid, let's also look at this here. There's a few things that I really like of the solution of Patrick Chan. He has decided to make the cells just a single dimensional array and not a 2-dimensional array, which is something that most solutions have that I found on the internet. This is quite smart, because this is making the code much easier, because we can calculate the row index, the column index, and the box index from here. And this is also something that is really smart. He has these 3 sets for columns, rows, and for the grids, which I call boxes. This is just like set, like a bit vector or a set of flags that indicates, is there already a 1 in the column? Is there already a 2 in the row? Is there already a 1, 2, or 4 in the box, for example, right? And if there is, then we cannot set it. Then it's not valid to set this number in this cell, right? Okay, so, but there are also a lot of things that are problematic. For example, all this documentation. There are even some bugs that I found, and so we will work on improving that. Okay, so enough talk maybe, or maybe we'll look at this. Here also it's mixed. This is also something that I would want to improve. Here we have, like, usually you should have something like a factory. This is a design pattern where you would create whatever you want to create, in this case the grid, and you would want to separate the creation logic from the actual algorithm logic, right? And this is here mixed. I mean, he wanted to have this short, but we want to have this object-oriented for this kind of short code. Some might even argue, well, you're over-engineering the code. Maybe I am. If you think so, that's okay. As I said, I want to teach you my strategy of generally doing a refactoring here. Okay, so he's here creating the grid, iterating over a file. This is the file that we're reading in. So there are the numbers, the dot is an empty number. The way he wrote this is also that there could be a 0, which would also indicate an empty number. So anything, a dot or a 0 would indicate an empty number, and he cares for that in his code, right? Now, here you can see that a dot or a 0 means empty cell. Okay, so then this is the actual logic. Find the next empty cell. Return -1. You know, this is the kind of not so object-oriented, more like C++ code. Now he has here the set method. Here, as I said, he calculates the row index, the column index, and the box index with these formulas. And here, this is the validation logic where he says, is it actually even allowed to put this given number at the given cell index, right? So he looks into the row, the column, and the box. Sorry. But he is using this bit fiddling. I'm not really a big fan of bit fiddling in Java code. I mean, from the one perspective, this is just really basic code from logic from computer science. But, well, you know, when I'm writing Java, then I'm not thinking in that kind of way. And I think it's a bit hard to understand and a bit hard to follow. Well, obviously you can go on the website and you can just read about this, like, what is this? I remember this was something like shifting. Is this now shifting to the left or to the right? Is the 1 shifted or is the number shifted? How many times is it shifted? This one, I think I remember it's an AND. So, you know, from binary logic, 1 and 1 is 1, 0 and 1 is also 1, or 1 and 0 is 1, and 0 and 0 is 0. Okay, this much I understand. But how does this work in combination? Here also, what is this here? I do remember that's an OR. But how does this work in combination? And here again, it appears again. And this one seems even worse, because what is this thing here? So, what can we do in these cases, right? So what I often do is that I would just write a code experiment. Instead of, you know, going to a website and reading about all this, we could go to we could run a code experiment, and I will show you very soon how to do that, because the code doesn't lie to us. Okay, so there's the clone method. And there's the toString method. The clone method also has some problems, but we will look at this later. Okay, so now finally, after lots of talking, let's start with my refactoring actually. So first thing, let's just mark all the code and let's just auto-format that, right? I think auto-formatting the code will not break it. My IDE should take care of that. I'm using here IntelliJ IDEA, which I really like. If you're using something else like Eclipse or NetBeans, they all can do that. And some might argue, well, you shouldn't auto-format the code. My personal opinion is you should, because the code should always look the same for everyone in the team. And we should agree on some formatting in the team. There are also other techniques. For example, you could do that with a hook when you check this in. Also good. But in any case, I think the formatting should be done as early as possible so that we don't mix up these check-ins with later on when we really do the refactoring. Okay, so we have now formatted the code, and now let's just continue with the refactoring things that are of the lowest risk, right? Because it's always about risk, we should go in really baby steps. And one thing that is really low risk is to let your IDE do the work for you, right? So here this has this inspection. Eclipse, I know, has also other similar ways. So we can go through this and it will already tell us a few things that we can fix. For example, here it tells us that this is not private, right? And I can just click, and with one simple click it made all these fields private, right? So this is a really simple way. Here, for example, also it says we can use a for each loop, or here string buffer can be replaced by string builder. Let's just do this, bam, and it's done, right? So we don't have the time to do all of this. So, but just to give you the idea, this is what we should do. And this very first step can easily take you an hour. What we should also do is we should work on the magic numbers. I mean, he has lots of magic numbers, and to explain that, he puts the comments here just above. But why not putting that knowledge into the code itself by using constants? So let's do this right now. So I'm telling this, let's say, no, sorry, this was method. Magic max number of cells. And the name in this case, I mean, you might not have the best name at the beginning. As I said, we are doing this in iterations, we're doing this in baby steps. You can always go back and improve this later, right? So spend some time to think about it, but even if it's not the perfect name, you can later on improve that. So now I will create actually a constant class for all the constants. Again, this might not be the final step. You might later on refactor that further and move it into enums or specific classes. But at the beginning, I think this is quite helpful to have one central place where all the constants live and where we can check what do we already have, and we will see there are patterns appearing and so on, and this will help us to better understand the code. So I call this now Sudoku constants, right? So now, wait a second, didn't find that. Not search. Okay, now it should work. Sudoku constants, yes. Okay, so add, yes. So now we created the class with just a click, and the constant is already there. And I didn't by myself, I didn't touch the code. This is the great thing. Now I can even remove that, and with another click, this is auto imported, right? And so on, we will do this for all the magic numbers. So this would be the unit size. Unit size, for example, because this keeps on appearing. And now I can copy and paste that a few times because this is appearing really, really often. So now I stop with these constants, so I will go on. I will also rename a lot. And you will probably obviously not be so fast because this will take you time to understand. So I figured out this is actually the cell index. So let's name it so. So names are really, really important, that they make sense, especially to you. And touching the code like this will help you to get a deeper understanding of the code, right? This also, for example, is the row index. So let's call this row index. And one thing that is probably even better, to extract this as a small method. Let's call this just row index. These are just stupid helper methods. And yeah, if you do this, you will work on making code duplication, which is a lot in the code, more visible. And so this is just one baby steps towards cleaning this up, right? This is not the final stage. Okay, so we will extract that. Here we can say column index and so on. So we will extract small methods, whatever is not risky for you, right? Whatever you can easily understand by yourself. Column, index. And in the same style, here it even helps me and finds this again, we should work on extracting Boolean methods. For example, here in the solver, we could say this one here, because this is what the comment says, right? Return if there's already a solution. So I could extract that as enough solutions found, right? Or this one here, by the way, if I click here, I'll find out this is returning -1. So -1 is like how he encodes there is no empty cell, right? So actually, I also find out that it's not just smaller 0. What is correct is, what he means here is equals to -1. And what he means here with -1 is no empty cell, right? So we can put that into the code. Extract as constant, no empty cell found. And if you continue like this, your code will be more and more speaking to you. And now again, this is the index, the cell index. Okay, so now I will again extract that and say, sorry, this is marked. Imported this as a static constant, and now I say no empty cell found, right? Now for whatever reason it didn't work. Let's do this again. So empty cell found. Okay, so I'll stop here. I hope you got the idea. We will now switch. We will now jump to the next version where I did already that and worked on that for like, let's say half an hour. Okay, so I'm just saying v2, and I've switched to the next branch that is now in a newer state. So here we have lots of constants now, and you can see how this like adds up to having several groups in the same region, and how this already tells us a story here by just looking at this, right? So now this is all a bit clearer, but there's still lots of things that we can do. Here we see there's a method. This is the update method, and what I don't like here is that it's actually not doing one thing, it's actually doing 3 things, right? It's first of all validating, can we do the update? And then second, it is doing here it's doing the update, and third, it is also filling these sets that indicate quickly for performance optimization, is there already this number in the row, column, or box? By the way, I also worked on sorting. Like now it's always row, column, box, because we speak of the row and column. So I put this in this order. And this will also help us to see code duplication much easier, right? Now you will see, oh, this is always similar, right? And while the code is now much better than it was before, I think, at least it helps me better understand this code. This bit fiddling now I would want to touch. And in my introduction, I already told you we can run little code experiments there to better understand this. And this is what we will do now, right? We don't have the time to perform all of this, so I have just prepared something. So the first one is I want to understand how this updating works, right? So let's look at the code. So we want to start with an empty bit vector of 0. And then we want to update this bit vector with the value of 3, right? So we're calling this function here. And this is just taken from the code that we saw before with the or, and this shifting, right? So let's just do this and see what happens. So I'm calling this. And now here. So I see the result is 1, 0, 0, 0. So we have 3 zeros when we put in the value 3. So this gives me an idea. So let's now put in, let's say 2. Because I'm not yet sure if my idea is really right. Now I have 2 zeros. So what happens if I put in another value, a 4? So now I update twice. So now I have this as the 4, because this would have been 4 zeros, and at the position of the 2, I have another one, right? So now I really understand this. This is why earlier I said it acts like a flag. So what happens if we put in the number 2 twice? Nothing. It's just as if we would put this in once. Because, I mean, obviously, if we look at the code, this is the OR, and it just checks left side and right side. And if there is 1 on the left side and 1 on the right side, 1 and 1 is 1. And even if you add another 1, it will stay 1, right? So this is an indication that we will never see when we updated it that it was already contained. This is why we have to validate before we update, right? And how about resetting? Here, I start again with an empty bit vector, and then I call the update function that we used before, and I want to put 2 in, and then I want to reset the vector again with the same 2. So I would expect that when I reset a bit vector that is set to a 2 value, that it's at 0 again at the end. Oh, and I didn't tell you, obviously, I mean, this is something that you have to know. This is working on binary logic, and so that we are able to actually see that, I'm using here this integer to string function that will operate on base of 2, so we will always see that formatted as base of 2, right? Okay, so reset, call that, and as I guessed, yes, it's working, it's 0. So, but what happens now if I just leave out that update and I reset the 2 on an empty bit vector? Will this give me an exception? Will this give me a negative number? Let's check out. So, no, it acts like the update. And this is kind of weird. This is like a bug, right? Because this is hidden in my code, and should I ever run into an illegal state, I would never see that. So this is something dangerous. And this is why this bit fiddling I don't really like. I mean, this is for performance reasons. If you need the highest performance, this might be okay. And this is also why, for example, Josh Bloch used that in his hashcode functions. Okay, I'll leave that to the experts. But in the average case where we don't care about performance, where we just want to have this working and it's fast enough and it's good enough, we want to focus more on code readability, that the code is object-oriented, that the code can be maintained quickly. And for all of this, it must be readable, right? So, and this is why I would want to replace this with some technique that is provided me by Java itself, and that is called a bit set, right? So now with that understanding that we gained, let's now switch, and I will work on, so this will take a while, which is why we won't see it. I will replace this with an array of bit sets which just do the same as this bit fiddling, and we can get rid of this bit fiddling now that we understand it. Because as I said, before touching something we have to understand this. Okay, so let's switch. Version 3, with one click, we are gone. Ta-da! Now we did a lot, right? So let's see what happened in the meantime. First of all, the grid. So here now, as I said, we have replaced, maybe let's make this bigger. Sorry, bigger. Doesn't want to go bigger. This is a bit... Okay, let's leave this now as it is. So we see we have 3 bit sets. I have extracted the isAllowed function, okay? And here, now I'm operating on these bit sets, and for isAllowed, I can just call the get, which will return me a Boolean only. So this is much safer. It just gives me the information, is this value already contained in my bit set or not, right? And this for the row, for the column, and the box. Same for the update. All we have to do is we call set. Set me this value in the bit set. I think this really speaks to me, right? And then the reset again, we just can call the clear method. Clear this value. It's like reset this value, right? So, and this will not have the XOR bug because it was an XOR that we had before. And that's why this worked as it worked, right? Because the operation behind this sign is an XOR, right? So this is safer. So now our code got better, but still we have all these helper functions here, right? And if I go over this code, I will soon see now this concept of cell appears really often. Everywhere we have the cells, the cell length, the cell index, here the cell, is the cell empty, and so on. And now that I worked a bit, this would have been a few hours in reality on the code, I have a much better understanding of the code, and now I think I'm ready to touch the code and to introduce a new concept to do. Yes, a new class is born, and we will call this class cell. Again, as we're short in time, here's the new cake, ready? I have prepared a bit, but as just before, we will still have to code a bit. This is not fully finished, just prepared so we are faster. So let's look at what we have already. I have extracted the file parsing logic because, you know, we want to have this object-oriented and we want to have this different concepts. We want to have them separated, right? We don't want to mix different concepts. And this is also called the single responsibility principle, or also we talk about cohesion, right? So here the cohesion is quite high because we, in this one class, we only working on one concept, which is file parsing. And this is not mixed with any kind of business logic. This is only and only about file parsing. So even if we had some other code not related to Sudoku, we could reuse that, right? This is a static method, and static is a bit smelly, but in this case, I guess it's kind of okay because it really has no state. Okay, but we should be careful with static in any case. This also, by the way, is using some very new function, I think from Java 7, which is quite great because this will also close us the file stream that is working on behind, which before was not happening with the file reader that we had. And it's just all doing this with a very few lines, super simple. Second, catching exceptions. This is also a big topic. I have a video only on that alone. So here I can only slightly touch the subject. Well, in my opinion, checked exceptions were a big wrong decision in Java. Java was the first programming language that introduced checked exceptions and also the last. So I think that teaches us something. An exception should be an exceptional case. So when evil things happen, well, we should handle them, right? And handle them means we should just directly catch the exception and then handle it. In this case, however, there is nothing I can handle. This is just a stupid example. If I can't read from the file, what can I do, right? Then probably I have a problem with my computer or the file is gone. So what can I do? I should stop the program and I should find why was I not able to read. Well, maybe because I deleted the file, right? So in this case, I would want to fix it, which is why I'm just stopping here. I'm throwing the exception and period and end. And by doing it in this way, by using an unchecked exception instead, I will keep my code clean. So I don't have all this throws exception anymore. So I think this is much better. Okay. Now, this we will look at later. Now here I have also a different class that is only working on the I/O, on the printing logic. Still not really clean, can still be improved, but it's all just in one class. So this is already more cohesive. Okay, and this is great. We have a factory, a static factory. This is a design pattern also, at least like a small version of the real design pattern. So in this class here, we have now all the creation logic. We have this separated from the actual algorithm, right? Because this is kind of a nasty logic. This is not really nice code, I think. And this is only done once initially. So we should keep this separated. Okay. Well, even, I mean, this code still has further problems because we should use something like dependency inversion, different topic again. But yeah, that much for now. Okay, so now we're here operating and iterating over the cells and creating the cell. Okay, and we have a runner. The runner is calling another static method. This is not so nice, but we did that. So we have our smoke test. This is what I said earlier in the beginning. This is not a perfect test, but the test at least will allow us to find if we ever broke the code. It will not tell us exactly in which line we broke the code, right? This would be even better. For this we would need unit tests, but within my video here, I won't find the time to write unit tests. But you, please write unit tests. Actually, I have written a lot of unit tests for this code. I just don't want to show them to you because time is not allowing that, right? But let's just run this maybe. So here we have the Sudoku runner tests. And we can run this. And No, this is the bit manipulation, sorry. So here, so this shows us green bar, it worked, our test passed, everything is fine. But now, let's just assume something in our logic is wrong, or let's just assume something in the grid is wrong. For example, if I put in here 1, then I would expect the test to break. And yes, it breaks. So even though this test does not tell us, well, Markus, the problem is you changed the file and you should not do that, right? That would be much better, obviously. But at least it shows us, please don't bring this on production. There is a severe problem. Fix that before going on production. So in the worst case, if you don't find it, and that's quite likely because finding that could take hours, just roll back your code, right? This is still better than bringing that on production or wasting hours of hours. If you just worked half an hour from your last commit where the test was working, well, then you lost half an hour in the worst case. Okay, so tests are super important. Now, finally, I said a new concept is born. We have this concept of a cell, and we should work on that. So let's do exactly that now. As I said, I prepared that. I have a cell class. I make most classes final because I'm not really a big friend of inheritance. Inheritance has issues. Again, for that, I have my own video. Can't go in details here. We should make classes as much as possible immutable, as much as possible final. The position class that is used by the cell class is even immutable because it's final. All the attributes are final and it can't be changed. There is no setting logic. It just is created once and never changed. This makes it immutable. Again, for immutable, if you want to learn more, I have my own video only for that. And now I have a central place where this logic of how a cell, a row index, column index, box index is calculated, it's all centrally in here. And should this logic ever change, we can change it in this one place, right? So this is much, much better than before. This logic was spread over the entire class. Okay. So now that we have this cell, let's just use it. You see, this is gray. That means it's not used at all. And we have here a static factory method again that will allow us to use the cell. That's quite neat, as you will see in a second. Okay, so let's now work on using that. So I'll make this a cell array. Now you could also say, why array? Couldn't we use a list? Yes, we could, but array is also fine, I think. So yeah, and as I said, baby steps. If we decide we want to have this as a list, we can do this even still at a later time, right? Now I can make this a for loop. For each loop, I can say cell for all the cells. And then I can ask the cell, are you actually empty? This method is not existing yet, so we will create that. Right, so with one click, create method. And then I say return value, which is an int, equals to empty value. I hope I wrote it like this. See? And now my constant class comes in handy. It directly catches that. That's why I love IntelliJ. This is really, really helpful. And I'm done. Okay, something is still... No, it's fine. Okay, so now this is working. And obviously we would return a cell now and not an int anymore. So, and here, at least at the beginning, we would return null. Returning null is also really a problem usually, so we shouldn't do that. We'll fix that at a later time. As I said, baby steps. Remember that always. Go in baby steps. One problem at a time, not everything at once. Okay, is allowed. We will directly do cell. Is empty. We could now again do this on the cell, but actually as a fact, we don't even need this first part. We can entirely remove that because the way this algorithm works, it calls this, finds an empty cell, so it should be empty. So this is guaranteed anyway. I mean, we could maybe want to have this code even more foolproof, so we could add an assert, but this is something else. So let's not do the assert right now, but let's just remove that because it's not needed. And this will make this a bit simpler. And here we can now remove all these extra brackets. And now also, and this is where this gets really cool, we can get rid of all these helper methods and we can directly call the cell and say, hey, give me the row index, right? Hey, cell, give me the box index. And when I see this, really, this is for me where object orientation really gets cool. Because this is easy, this is readable, this is fun, at least to me. And here, box index. Okay, so something seems wrong still. Return get the value, box index, column index. Okay, let's leave this for now. Okay, we'll check this later. So again, cell, here again we will say cell. So here I can directly update the cell and say update with this new value. Maybe I should even say new value to make this better readable, right? And now this method is obviously missing. So I will say this, this dot value equals to new value. Again, my IDE helps me, which is really kind of cool. So, and this is what makes this, as I said, more readable, right? Again, here we can do what we did before. I can say row index, and I can say here column index, and here I will say box index. Okay, so, and this will be new value. Okay, reset is the next one, so we'll also say cell. And here again, we will create a new method and we will say, oh no, this one we have, right? Value. For int value, obviously, you could also create your own value enum or class. Here I decided to keep this simple. It always depends, right? Never overcomplicate things. It depends on the size. And here I decided to keep this simple. I have a different version where I refactored that, and I did introduce a value enum. It's also valid. And enums are cool because they're immutable by definition. Because we should always try to make things immutable. Okay. As I said, that's a different topic. I have my own video for why you should favor immutability. Cell.column index, and as before, cell.box index. And one thing, I mean, that you might now feel, I did this very often now, cell.row index, cell.column index, box index. And this is, as I said, you know, we're iterating in small steps. And the more we do this, the more we will find more and more code duplication that we can in a later iteration fix again, right? So at the beginning, you will just not see that because there's just too much. But the cleaner the code gets, the more you notice, oh, wait, this seems to be really similar to that one also. So we should maybe touch that also. We'll do this at a later time. Okay. So, and this is here resetting the cell. So why not directly doing that? Cell.reset, right? This is also missing. We'll copy the empty value. Now we create the method, and we say this dot value equals to empty value, and be done, right? We could also create our own toString method. This we would do at a later time, because the cell then could print out the dot for the empty cell and not the 0, and could print out and could do all this in a toString method. Okay, so once you have this concept of a new class, in this case cell, this will allow you to improve the code a lot. So here, let's use the cell, and the whole logic here could be so much simpler if we would iterate over the cell array in a for each loop. But again, I'll not do this now. I would do this later, right? So now let's just do the minimum steps needed so that the code compiles, right? To minimize the risk that we introduce a problem. And now I'm probably back with the problem that we had initially, yes. And in the meantime, I also had a bit of a moment to think about it. probably there is a problem with the brackets, right? So let's check this. If not row bit set get value and not column bit set cell column index get value and not box bit set cell box index dot get value, and it wants another bracket, yes. But where is the bracket missing at the moment? I'm not seeing it, to be honest. This one is fine. This one. Ah, this one. Yes. Okay, so now I found it. Okay, so this is a live refactoring, and yeah, this can happen. Okay, and now you will see, actually, we can get rid of these methods here, right? Ta-da! So some code duplication is already removed. And we're not done yet, as you might have thought. There is more. So here we have to use the cells, and here we can directly iterate probably over, let me see, should we do that? Yeah, I guess that's fine. Let's see, cell of the Sudoku cells. Okay. So now getting the value is just cell.value. Okay. And now cell.row index. And see, we do this all the time now. So now more and more we feel the pain. This should be improved. Cell box index. But let's not touch this now. Let's think about this at a later time. Okay, and now this is not int, but cell. Okay, and now in it is also cell. Okay, and now we're getting there slowly. Cell, new cell. Okay, what else? Yeah, here we now have to, this is a bit still nasty. We have to use the index now twice. This is a place that I would want to improve at a later time. But at the moment we have to do this in this way. Because we need the index now that we're object oriented, we're creating a cell. And here, as I said, I'm using this factory method here. I think that's pretty cool. By the way, here I simplified this in the meantime. So I'm saying, is this a fixed value or is it an empty cell? And empty cell can be the dot car or the 0 car, right? And value, fixed value is between 1 car and the value 9 car. Okay. So this is not optimal yet, but at least this should be working. And this is the first thing that we should fix. So here we still have a thing that we should fix. Okay, so cell, obviously cell. So see, I called the test. I thought it was working when it was not. So here this is helping us. I still have to do something. So cell, this obviously doesn't make sense now, is null. As I said, it's not nice. Let's improve this later. But I think it's getting nicer and nicer step by step. Okay. So let's try again. And now, green bar, this worked. Ta-da! So we know we could now theoretically check this in on production and be good, right? So now let's, time is already too far. So let's now just look really quickly what could have been done if the time was bigger, right? So this is a more even further improved version here. We're using some Java 8. I'm using here some new functionality with an optional. Some might disagree with me and say, hey, this is not the way the optional should be used. I'm just abusing this style because I want this more readable, and I don't like to see this now because now has empty cell, find empty cell, is it present? This really talks to me, right? And here I'm using a stream, array streams on the array, filter me those that are empty, find me the first. So this now really speaks nicely. Is it allowed to put this value into this cell? Okay, wait a second. There is a helper method, row bit set, right? So this directly works on the correct, using the row index, finds me the correct bit set. Now this still has code duplication, and this could still be fixed by using more functional code, for example, but the question is, okay, this will fix the code duplication, but will the code still be readable? And this is why in this case I decided against further simplifying that, and I was fine with that. So it's always a balance, right? And you might disagree with me, which is fine, right? So you can do this a bit differently. In any case, I think this code is now much nicer than it was before. And yeah, so I stop here. I hope you learned something from my little refactoring. So this is how you can do a refactoring. Try to gather as much as knowledge about the business that you're in. Start with the easy stuff. Start with the stuff that you feel comfortable with. Let your IDE help you. Do as little as possible manually, right? Always use your IDE with renaming, with extracting constants, with extracting methods. Let your IDE do that for you, right? And as soon as possible, work on creating tests. In the first case, just a smoke test that shows you something broke is okay. But then the more knowledge you gain, add a lot of unit tests. Think of the test pyramid. But okay, I'm going too far. That's again a big topic. Okay, so thanks for your time and see you next time.